Today let us discuss about a constraint-based optimization problem called as flow networks. Flow network is a directed graph. So each edge in the directed graph is associated with the capacity. So where we apply this flow network concept is that if you want to optimize something, you can go for max flow problem, flow networks, and it can be solved using many algorithms. And in this video, we are going to discuss about code Wilkerson algorithm. So let us start with empathizing the problem.
So when we look at the empathy of this problem, so the main constraints are flow, capacity, and for let's take a real world problem where the water from a tank to our sink. So where the pipes may be in different sizes which have different capacities. So the flow can't exceed the capacity. So it has to be come in a proper way. Well, the minimum capacity is the maximum flow of the entire connections.
Based on this empathy, we can understood that the problem is not the number of a pipe. It's up to the number of a bottleneck. In graph term, we can say it's a mini cat. What is the mini cat? It's a set of the edges which removes and separates the water source from the city. And for important thing, the total capacity of the water is depend upon water can supply that. And if the water source has unlimited water, we cannot send the all water to the city. It's only depends upon the bottleneck and capacity of the pipe.
So now let me discuss the how to solve the flow networks. So here is the to reach the target from the source 1, 2, 3 to 5. So now from the 0 to 1, 3 to 5, which is a minimum flow. Ashim, can you tell which is a minimum flow?
In this,
0, 1, 3, 5.
I think it's 0 to your next.
Yeah.
Yeah.
0 to 5. I took this far. Which is a minimum capacity.
12, right?
Yeah, yes. So now 12 is the minimum capacity here. So here 12 is equal to 4. So 12. Here minimum capacity is equal to flow. So if capacity is equal to flow, then the path will be get blocked. So let me choose another path now. 0 to 2, 2 to 4, 4 to 5. So 0 to 2. Can interest tell what is the minimum path? 2, 2 to 4, 4 to 5. 4, yes. 4 is the minimum capacity here. So, then 4 will be blocked. So, here 4 is the minimum capacity. Now, let me choose any other path. Is there any possible paths?
Yeah, we can go to 0 to 1, 1 to 2, and 2 to
0 to 1, 1 to 2,
2 to 3,
2 to
4,
2
4 to 4, 4 to 3, 3 to 5. Okay, fine. Now, what is the minimum capacity here?
7.
Yeah, 7 is the minimum capacity. Now 7, this part is get blocked. So 7. Now what is the maximum flow here? 16.
20.
So 20 is the maximum flow.
Okay. So coming to the prototype, building the flow increment by increment. As Bharatosh mentioned, you could imagine an pipe flow through your tank to your sink. As if I was sending in 10 unit of water through the north side pipe, then it gets filled due to the pipe's capacity. So then I would deviate it to the south pipe. By this, we are layering the flow of the water through pipe by pipe, and we manage to get out through the output. So this is what the prototype flow would look like in a real world application.
So to evaluate the final results, we need to make sure that each and every pipe is filled with water, up to its complete capacity. You have to make sure that no pipe is left unfilled. It's either need to be filled or it need to be blocked. So through this, if there is no any possible ways, we can make sure that the water has reached the maximum flow. So through this, we can assume that the solution was a success and the water flow is proper in every area.
So as we have seen, the algorithm adheres to the constraint that the flow should not exceed the capacity in finding the final solution. So at every stage, we find the maximum flow through each path, and this each path is called as the residual path. And the final maximum flow that we are determining gives the augmenting path. So this augmenting path is used to find the optimal solution. So irrespective of the algorithm that we use to solve the flow networks, max flow problem, you will get the same answer. This is not only used in solving the real world water crisis, but it is also used in various other applications. Like if you want to lay a network, you can also go for this max flow problem.